7th grade math. This is 4.4 in your book, least common multiple. And it's kind of the same, you know, with the 3 letters like greatest common factor. We're going to talk about how this is different than that. I mean, obviously they're different words. So 182 in your book. First off, let's talk about a multiple. A multiple is defined on page 182. It says it's a number. The multiple of a number is the product of that number and any non-zero whole number. I like to say it this way, for, you know, multiple, multiply is another way to think of it. Multiples of 2 are 2, 4, 6, 8, 10, and so on. Multiples of 3, 3, 6, 9, 12, 15, and so on. So when they say a multiple is the number of a product of a number is the product of the number in any non-zero whole number. So this is like 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, and so on all the way up. And I always used to remember it as you're just counting by the number. So I want the multiples of 10, count by tens. 10, 20, 30, 40, 50. I want the multiples of 5, 5, 10, 15, 20. Okay? Common multiple is also defined. It is multiples that are shared with numbers. For example, 6 and 8. Okay? If I count by sixes, 6, 12, 18, 24. 8's 8, 16, 24. 24 would be called a common multiple because it's common, it's in both lists. It is shared in both lists. Now it's also 24 is also the least common multiple because it's the smallest number that 6 and 8 can go into. Okay? So they define the least, it's just the smallest, least common multiple. Alright, so let's do some of these. Example number 1, model trains. It says, 2 model trains share a station. They run on separate tracks. One of the trains returns to the station every 4 minutes, the other one every 6 minutes. Both trains just left the station. When will the trains next return to the station at the same time? So least common multiple is when things happen maybe at different intervals, like every 4 minutes and 6 minutes, and you want to find out when they're going to happen at the same time. So let's write 6 and 4, and let's write out the multiples of 4. 4, 8, 12, 16, 20, 24. And I'm going to stop. Usually you should only go about 4 or 5 and then stop. 6, 12, 18, 24. And you're going to notice something right here. 12 happened in both lists. Also 24 happened in both lists, but it wants to know when will the trains next return to the station at the same time. What's the least common multiple? That would be in 12 minutes. Okay, and so they tell you to list the multiples, and they wrote out a lot farther. Every 12, it's increments of 12 that they will return. So find the least common multiple of 7 and 8 by using a list. So it's very important you do which method they say. We'll talk about 2 methods to do it. This method is making a list. So we just list out the multiples. 7, 14, 21, 28, 35, 42. A lot of people can add by 7s because of football. 8, and if you can't count by 8s, just do 8 times 1, 8 times 2, 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. 48. 8 times 6. 8 times 7 is 56. 42, let's just try to catch this one up, would be 49. And 56. 7 times 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. So the least common multiple of 7 and 8 would be 56. In other words, 56 is the smallest number 7 and 8 can both go into. 7 goes into 56 8 times, 8 goes into 56 7 times. So there they're listing out the multiples, and then they stopped when they got to 56. Okay? Now, another way to do And I don't know why the guided practice, let's see, let's come back and see if we might be missing some guided practice here. Sorry, I didn't look at this very close. We are, look at that. Let's see if it happens to be. It's not. Okay, let's go back. And we'll do this page by hand then before we do example number 3. Okay? So the guided practice after example number 2, let's do those. Starting at the bottom of page 182, just forget about this for right now. Okay, so number 1, it says, find the LCM of the numbers by listing the multiples, so 3 and 5. So 3, 6, 9, 12, 15. And I know I can stop because 5, 10, 15, the LCM would be 15. Okay, number 2, 12 and 16. Start with the number and count by 12s. 12, 24, 36, 48. 16, 16, 32, 48. The least common multiple is 48. And I know some of you know them by just looking at it, but it's still, we're practicing listing the multiples, so still list it like this one, 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, so the least common, there it is, 90. Number 4, now look at this one, has 3 numbers, 2, 6, and 14. So you have to make lists of all of these numbers until something matches. 2, 4, 6, 8, 10, 12, 14, 6, 12, 18, 24, 30, 36, nothing matches yet, 42, 14, 28, ooh, 42, I know 2, I won't write them all out, I know that's going to hit 42, so my LCM would be 42 for that one. Alright, we are on number 5. We got 15 and 20. 15, 30, 45, 60, 20, 40, 60. Number 6, 7 and 11. You know it's going to be 77, right? 7, 14, 21, 28, 35, 42. I can write, my pen goes crazy, 49, 56, it's 9 times that, 63, 70, 77. 11, 22, 33, 44, 55, 66, 77. Say, write out the lists. I know it's kind of a pain. Do it anyway. Okay, a 3 and a 12 and a 15. If you can kind of know what the answer is ahead of time, okay. I know 3 and 15 can go into 30. Oh, shoot. I think it's going to be 60. 15, 30, 45, 60, 12, 24, 36, 48, 60, 6, 9, 12, 15, 18, 21, 23, no wait, 24, 27, 30, halfway there, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60. So my LCM is 60. Okay, last one, number 8, 21 and 84, 21, 42, 63, 84. Look at the first one for 84 is 84. So the least common multiple is 84. Whew. All right, well, I don't know about you guys, but I don't like writing out all those multiples. I think that makes it hard. Okay? So what we're going to do is talk about how to find the LCM using prime factorization. I don't know about you guys, but I would not want to write out all of, actually the answer to this problem is 2,520. You would have to write all of those out until you hit 5,000 or 2,520, which would take a while. So let's talk about a way to do this. A different method using prime factorization. Just like in the GCF, you take 84 and 360 and you do the tree. Okay, now I'm going to do that. They already do it, so there's no reason for me to write it out. Okay, so there's the tree, and there's the answer to the tree. Now, I might explain this a little different than the book. What I do is I write each answer using exponents. Remember, in the greatest common factor, you wrote them out in the expanded form, but you want to use the exponent. So it's 2 squared times 3 times 7 for 84. 36 has 1, 2, 3, 2, so 2 to the third times 3 squared times 5. And you want to put them in numerical order, okay? Now what I do is I go through and I look at the numbers and I pick the number that has the biggest factor for each one. So I start with the 2's. 2 squared and 2 to the third. 2 to the third is bigger than 2 squared, so you circle that one. 3 squared is bigger than 3. There's only one 5, so it's bigger. It's only 5. And there's only one 7. You take the numbers that you multiplied together, or that you circled, and you multiply them. So that's 2 to the third is 8 times 9 times 7 times 5 is 35. 8 times 9 is 72. 72 times 35. Add a placeholder. 5. So your least common multiple is 2,520. Now you could have written out your factors, but when the numbers get big, this is the best way to do it, because I always find the more work, the less steps, the less chance for error. And I'll do more of these so you guys can follow. And I'm explaining it a little bit different than what the book does, but they agreed with us in our answer. So example number 4, tour bus schedules. 3 tour buses leave the visitor center at 9 a.m. Bus A returns to the visitor center every 60 minutes. Bus B returns every 40 minutes. Bus C returns every 75 minutes. What is the next time the buses will return to the visitor center at the same time? So now this one right here, again, the numbers can get kind of big, so let's practice this with the trees. So we do a tree for 60 and get 6 times 10, 2 times 3, 2 times 5. So 60 is 2 squared times 3 times 5. Okay, 40. 4 times 10, 2 times 2, 2 times 5, so it is 2 to the third times 5. 75 is 3 times 25. 25 is 5 times 5, so that's 3 times 5 squared. Now you go through and check the 2's. What's the biggest 2? 2 to the third. What's the biggest 3? They both have 1 3 right here, so if it's a tie, you just pick one of them. And then the 5 squared is bigger. So 2 to the third is 8, 5 squared is 25, and then the 3. I know 3 times 25 is 75 times 8. They would be back there in 600 minutes. So the question says, at what time? When will they be at the same time? 600 minutes. There's 60 minutes in an hour. It would be 10 hours. And what time did they leave? 9 a.m. 10 would be 10, 11, 12, 1, 2, 3, 4, 5, 6, 7 p.m. at night is when they would all be back together. So there's their tree, the answers to their trees. There's them getting the biggest of each, and then there's the answer. So find the LCM of the numbers using prime factorization. So 36 would break down Let's do 4 times 9, 2 times 2, 3 times 3. So 36 is 2 squared times 3 squared. Okay, 72 is 8 times 9, 2 times 4, 2 times 2, 3 times 3. So 2 to the third times 3 squared. So what's the biggest 2? 2 to the third. The biggest 3, there's a tie, so you pick one of them. These right here I know equal 72, so my least common multiple is 72. There we go. Let me erase. Okay, ask if you're not sure. I'll do some of them with you. Let me do these over here so I don't write over the answer. 24 is 2 times 12, 2 times 6, 2 times 3, so that's going to be 2 to the third times 3. 30, and you might get to where you can do the prime factorization in your head. Okay, so the biggest 2 is 2 to the third. There's 1 3 for a tie and 1 5. I know this is equal to 24. 24 times 5. 120 is the least common multiple. Well, they have us practice these, don't they? 54 is 9 times 6, 3 times 3, 2. So 2 times 3 to the third. 126. When in doubt, it's even. Chop it in half. Half of 100 is 50. 26, 13, 63. 7 times 9, 3 times 3, 2 times 3 squared times 7. So the 2 wins, this one wins, this one wins. That's equal to 54 because it came from this number. 54 times 7, 378. And yes, it is. Yay. Okay, let me erase. 20 is 4 times 5, 2 times 2. So 20 is 2 squared times 5. 22 is 2 times 11. That's easy. 55 is 5 times 11. Okay, so the biggest 2 is the 2 squared. 5 happens twice for a tie. 11 happens for a tie. So 55 times 4, 220. Right, that right. Look at there. Okay, what if, suppose bus A returns every 30 minutes, 20, and 45. Okay, I'm going to try to do this in my head. 30 is 5 times 6. 6 is 2 times 3 times 5. 20, 4 times 5, 2 squared times 5. 45 is 5 times 9, so it'd be 3 squared times 5. So the biggest 2 is 2 squared. The biggest 3 is 3 squared, and they all have a 5. So that's equal to 45 times 4. 180 is minutes. So there's 60 minutes in an hour. 60 goes into 183 times, so 3 hours. What's the next time? Remember, it left at 9 a.m. So in 3 hours it would be 12 o'clock straight up noon. Whoa, look at that. All right, so you're doing 2 things there. You're finding the least common multiple by listing the multiples, and then you're also finding the least common multiple by prime factorization. So that's it. We're going to stop right there, and we will see you. Oh, look, there's the guided practice for the first ones. Isn't that nice for it to be at the end? I had a feeling that's where it was. All right, we'll see you next time. I'll try to go through that and fix those. Bye.